Okay, we've been looking so far at some of these different compounds, and one of the things that we need to do for your homework is we need to categorize a whole bunch of different chemical compounds into whether they are an ionic or a polar covalent or a nonpolar covalent bond. Now, as you can see here, I've taken some notes already for you, so let me just go through this. In an ionic bond, it's typically when you have a group 1 or a group 2 metal, and it's joined with a group 16 or a group 17 non-metal. It could also be a group 1 or a group 2 metal with a polyatomic ion. Now, that's the general rule, but sometimes it helps to actually calculate out something that's called the electronegativity difference. Okay? Now, if you look at the back side of your periodic table, you'll notice that in the upper right-hand corner, there's a bold number. This is on the back side of your table, okay? There's a bold number that says electronegativity. And what you need to do with that is you need to look at the elements that are in your compound that you're trying to consider if it's an ionic or a polar covalent or a non-polar covalent. And you need to take those two different elements and subtract the numbers, okay? So let me just show you some examples of this, okay? So let's say some examples of ionic bonds would include NaCl, or it could possibly include, let's do BaO. So you'll notice that we have here a metal from group 1 or 2 and a non-metal from either group 16 or group 17. Now, the way that we're going to do this is we take and we find the difference between Na's electronegativity and Cl's electronegativity. Now, Cl has the largest electronegativity, which is 3.16, and then we subtract Na's electronegativity, which is 0.93. And when we do that, we are able to find that the difference in our electronegativity there is 2.23. Now, 2.23 is greater than 1.7, and so we can know for sure then that this is an ionic bond. Now with BaO, we do the same thing. We find O, and on your periodic table when you find O, it says 3.44 is its electronegativity, and when we find barium, it is 0.89. And so again, we subtract these numbers, and what we find is that this then has a difference of 2.55 for its electronegativity. That is again greater than 1.7, and so as a result, this is going to be then a ionic bond. Now you'll notice that there can also be, though, where we have a group 1 metal with a polyatomic ion. Here we have sodium with sulfate, and again, if it's a group 1 or group 2, we can generally say, if it's with a nonmetal, that it's going to be an ionic bond. So what about the covalent bonds? All right. Well, let's go through this. Here are some different examples. H2O would be an example. One that you really want to think about would be arsenic. Okay, with oxygen, that would be one. And then also some others you might not think about would be C6H12O6, which is that lovely compound called glucose that you should remember from cellular respiration in biology. Okay, now let's look at the electronegativity differences. Again, polar covalents in general are two different nonmetals, and here we've got hydrogen and oxygen, both nonmetals but different. Arsenic is one of those that's a metalloid. It's right there kind of on the line. You'll find some of the other metalloids are going to act the same way, and they are acting as a polar covalent bond. Over here we have carbon and hydrogen and oxygen, okay? And there's really not much of a difference at all between carbon and hydrogen, so we'll be looking at the difference between the other two. So let's go ahead and calculate then some of the electronegativity differences here. We have, again, oxygen, which is 3.44, minus our hydrogen, which is 2.20. Now when we do that, take our 3.44 minus our 2.20, we get 1.24. Notice that's less than 1.7. Because it's less than 1.7, it's a polar covalent bond. What about arsenic then and oxygen? Again, oxygen is 3.44 minus the arsenic. And if I can find my arsenic here, arsenic is 2.18. So we take this, the 3.44 minus the 2.18, and we find, again, 1.26. Again, that is less than 1.7. It's a polar covalent bond. C, H, and O, well, we could really do about any of them on this, but I would suggest let's just do with H and the O on it. Again, we can see that 3.44 minus 2.20 gives us that 1.24. That would be the difference between the H and the O. Between your oxygen and your carbon, we would have 3.44 minus 2.55. And when we do that, we get a 0.89. And so again, still less than 1.7, so we have a polar covalent bond. Okay, nonpolar covalent. In general, this is when we have two identical elements that are stuck together. These are the Hofbrinkels, okay? H2, O2, F2, Br2, I2, N2, and Cl2. So Hofbrinkel. Yeah. Okay. That's an example when you, obviously if you take oxygens minus oxygens, you know, in that compound, you're going to get 0, okay, for your electronegativity difference. The other one that you can have is the difference is if you have like a compound that's like CH4, and in this case CH4 would be where we take our carbon, which is 2.55, minus our hydrogen, which is 2.20, and when we do that, you'll notice that we get 0.35, which is less than 0.5, and so as a result, these are examples of nonpolar covalent bonds. Again, ionic, typically group 1, group 2 metal with a nonmetal, or with a polyatomic ion. Polar covalent, two different nonmetals. And then nonpolar covalent, it's two identical nonmetals that are stuck together, or just a carbon-hydrogen compound that only has carbon and hydrogen in it.